Hello everybody and welcome back again in the third session of ETABS 2018 version 18. In this session we are going to know how we can model the 3D RC building, residential buildings that we have into ETABS. So recently we have been work on AutoCAD, how to convert or import the AutoCAD file into ETABS. So after this process, we have been prepared three DXF files from AutoCAD for basement, ground floor, and typical stories and roof. Let me remind you, the DXF files that we have been prepared. This one for the basement level of the building. The basement level is containing about this the gray scale, the gray boundaries is base look like foundation, and the blue color is the column, the red color is shear wall and cold wall. And here we can see again the ground floor. The ground floor will have different shape structure layout than the basement. We have the ground floor, we have the openings, we have the walls, and be careful that you should use the location of the UCS global axis in AutoCAD to be at specific locations that have the all on the all building. See, here we have the shear wall, we have the same location, we have here the same location, we have also here the same location of the typical stores with different layout. And for the roof level still have, so the core or the lift or the shear wall have the origin of this building. So now let's go to ETABS and try to insert all this information or all this AutoCAD files into ETABS to start preparing the model. So I'm back to see the ETABS version 18. As we know that we need to make a new model. The first thing you should do the new model, initialize the option, put the settings, metric, American code for the concrete design, and say OK. So in our case we have irregularity building, so we make this one custom grid spacing. We are not going to use grid system at all. We are going to use a blank. We have 10 stories with typical height 3.2 meter, and we have bottom story height 3 meter. So let's go and try to name each story alone. The story number 1 would be the ground floor level, GF. This one will be the first floor, second floor, third floor, fourth, fifth, and sixth, seventh, eighth, and roof. So we have here all the story level. We have the roof level. Just to know. So we need to make the modeling for this building. Select blank and say OK. So now we have prepared the layout. Now the first thing you should do is to know this is on reinforced concrete, right? So the reinforced concrete is the material is concrete, is RC. So first thing you should do and put in mind is to define the material of this building. First step, define the material of this building. We go to the stage, define material properties. There's several things here. Go modify show property. This one for steel, FY50. This one for concrete, 4000 psi for concrete, and this one for the grade for rebars, and this one for post tensioning or tendon or cables. So in our case, we have 4000 psi for the RC building for the concrete material. Let's assume that we have 30 megapascal strength of concrete. So this is concrete, isotropic, of course. We have to change this, for example, to 24 kilonewton per meter cube. The modulus of elasticity. There's an equation for the modulus of elasticity that I follow in the American code or ACI code, which is 4,700 multiplied by square root of the f prime c, which is 30 close 0.5. So this is the equation 4,700 radical or square root 30 for 0.5. You will get the in megapascal, the modulus of elasticity, and make sure that you change the strength from here from 27.58 into to 30 megapascal. So in this scenario, you are defining the concrete strength, the concrete stress, which is 30 megapascal, and you should take into consideration the modulus of elasticity in MPa, which is 25,742 based on our equations that we have been used in ETABS or an ACI code. So we define this one, and let me put the equation here, or try to write it. 4,000 P equal 4,000 square root f prime c you'll get in MPa or Newton millimeter square. So this is the equation for defining modulus of elasticity. Okay, so this is the equation you need to follow, and my reference is ACI code. Okay, so please follow this one through, and you can continue to define the material again. Here we have defined this one, 30 megapascal. And now we are going to define the rebar, which is still the same. It is the same for the 200 gigapascal or 200,000 megapascal. The same we have with a prime C. I will keep it the same also. Maybe I can change this to 420 as a yielding. I will change this one only for the yielding. So I have rebar 420 megapascal. Okay, so we define the material. After we have defined the material, let's start inserting all the AutoCAD files into the ETABS file, and make sure all the ETABS, all the AutoCAD files are closed. I'm trying to close it now. Okay, because we don't need any problem to be happen during inserting. So file, import to architect plan. We have 3-4 files. So I want to start with the ground floor level, or I can start with the typical stories because I need to put all the columns from the top to the bottom. Typical stories. I'll go to roof, 8 stories, that is 4 in there. Say okay. So we have in the plan view the 8th floor plus plan view, 8th floor will have this layout. Because we have one story, I'll make it all stories because all the columns from the 8th floor to the bottom have the same sections and are continuous from the top to the bottom. Okay, so now go to option, architect option, deselect all and go to ETABS columns. So now we have all the columns. There's option here for the drawing bars. We have draw beam, we have draw quick beam, we have quick draw columns. We are in this situation, we need to go to quick draw columns. So the quick draw columns, this is the steel. I want to use steel, use concrete column. I have to use sorry, architect for all stories. So select all and drop. See, view all the columns now. I'll drop. And let me show you the 3D or the extruder view here. All the columns are same. Let's continue. Have also an option to what? See the tabs walls. Okay, we have the tabs walls. We need to go to know the section of this wall, know the section of each tabs. So this one is 0. This one is 0.25. So we have the thickness here is 0.25. We have here 28.6. We have here 0.25 from 0 to 0.25. So all of these are 0.25 meters to 25 centimeters. This one should be, or let me go to see the AutoCAD, maybe I can see it better from AutoCAD. So we return back again to see that the thickness of the wall is 30 centimeter here. So go and define section properties, wall section. We have we can modify this, change this to wall 1, 25, with 30 megapascal, and copy wall 2. So wall 1, I will name it wall 25, but no, it's 20 cm, and wall 2, I will name it wall 30. Now we define the wall using quick draw here. Go to wall 25 and wall 30. Let's start with wall 30, which is for all stories. Okay, here we put for the roof, but we need to fix this later. Okay, so this is for the door, and now we are going to use for the shear wall. It's all for, you can see this in 3D view. Let's So now for option for the slab, select all and use slab, slab. It will not be for the whole, it will be only for the typical system. So I will right click, modify, I will take 8 is the master, and 7th will be following or similar to 8 number slab 8. Okay. So it's similar. So we change this to similar stories. Option, architect pan option, select all and use the tab slab. And we can draw by quick draw floor to change the slab. So I'll change this to architect layer and select all, option, architect, select all, and see which slab take. So from 8 to the first floor, you can see here the first floor is the same. So we still have need to put the ground floor and the basement. Okay. So now for the roof, let's go for the roof. The roof option, architect plan option, select all. We need to insert file, import, architect plan, roof level. In the roof, make it overwrite. Okay. So now we know the column location that we have, and we can delete all the columns that we have been modeled surrounded. So all stories, sorry, not all stories here. One story, and delete. So in this case, we have 8 floors the same. The roof has different criteria to follow. Option, architect plan, select all, and use ETABS slab because we already have done the wall and the column from the previous AutoCAD file or from the typical stories. Now we are going to draw the slab. One story, be careful on story and select option. Again, architect and option, select all. And now you have this layout, and now you see here that we have the story level and the shear wall and the core wall and the slab. The column. Now we need what else now? We have to put the ground floor. So in the ground floor, we need to put the slab for the ground floor. Option, make sure that everything is to select, and make sure that we need to import architect plan and make ground floor level at the ground floor, and make sure the units, as I say before in the previous session, that metric and the ETAB should be metric in AutoCAD, and overwrite existing CAD. Okay, now we have the layout for the ground floor, and option again, architect plan, select, and use ETABS slab because we have different boundaries. And for one story, option again, architect plan option, select all. And now we have done for the ground floor, for the roof, and for the typical stories. We still have to add the retaining wall here from the basement level. Let's go and put in the ground floor level, and option, architect, select. Okay, now we need to import architect plan option and add the basement level in the ground floor stage. Overwrite. Why overwrite? Because I need the wall to be here from the top to the bottom to be inserted. So this wall also we will consider it as wall 30, or I'll consider it as wall 35. Define our section, wall section, wall 6 here, wall 6. I have 30. I'm going to change this, add a new property, and make 135. Let's 150 here. So we have wall 35. And choose this one and change to wall 35. Right click, convert to ETAB wall. Right click, convert to ETAB wall. And right click here. And we can add, we are trying to add the retaining wall. Link to option, architect and select all. So now we have in the ground floor level, we have the basement. Now it is continued and completed. Roof option, architect and select all. Let me see, because I have noticed that here we have defined section or section. I mentioned I see wall 6 with 2, 4, 5. What is wall 6? Let me see. Right click. This is wall 25. This is wall 25. This is wall 25. This is wall 25. This is this one. or I can go to display, or select object type, properties, all section, it is all 6. There's nothing called all 6, so I think we should remove this. Here, you can see here. Here we have all 6 and the 84. So all 6 should be removed. Okay. And now we can add option. I have another option which is to select one story 25 and replicate to 8th floor from 8 from 7 to 8. So edit did replicate story 7, story 8. Now we have 125, we have 5. So this mistake could happen in modeling, so be careful. So I try to make this again. Select define section for the front section. We have the print section here. Define section properties for all section and define section properties for all section. All 6 should be deleted. There's no more all 6. So now from 8 to the roof to the ground floor is the same. So we still have to add the opening for each story level. So for the shear wall option, architect option, select all, and for the E-tabs opening, this will be an E-tabs opening here. Option, architect, E-tabs opening. Okay, we need to insert file, import architect plan and typical story level and the typical straight. Okay. So now we have the opening here layout and option architect plan. Select all and go to E-tabs opening. Now we need to draw E-tabs opening for similar stories. Quick draw changes to opening, and as an arch layer, we should do this. We should do this for similar stories. This one have its own shape. We should do this one. We should do this one, and just post it so. So we have from 8 to first floor is the same. For this one, for this one. So from 8, the first floor should be the same because we have similar stories. Option architect plan, select all, and now we have to see the rest for the GF. For the GF, we have one story, file, import architect, and good. ground floor. We have this. We have one story only. So opening orange option. And with that an option select all. We have the tabs. So from here you can draw the opening for one story. Make sure it is one story, okay? Not be replicate in other stories and select. So architect, select, and now we go down. Here would be 3D view. We can see that the openings exist in the whole building, and we still have to do for the roof. For the roof, maybe we can use another technique. I can use the technique of replicate. You can another option. Just select the opening here and go to the top and see the replicate story to the roof. So now we have opening here. Also, you can use the replicate in your modeling. Architect and select all, and now you can see the 3D view that this building now is completed. Okay, so after the stage, we need to go to select the need to select the boundary condition for the building. You can see the boundary condition for the building is UX, UI, UZ, which means the building have pin connection, and usually we go to do the fixed connection. UX, UI, UZ, and RX, RY, RZ. How to do this? Make sure you are selecting one story here. Okay, so select all the boundary condition and assign, joint, restraint, and make it fixed. This fixed. This is pin. This is hinge. This is nothing. So fixed fastest, or you can click from here, rotation. So this one will make you restraint in X, Y, Z and RX, RY, RZ and the 6 degree of freedom and apply. That's okay. You'll see now the joint constraint now is changed. Now you can see the joint constraint. Here, right click UX, UI, UZ, RX, RY, RZ. So now we know that we have defined the walls. The wall is right click. You can see wall 25. We now need to define to check the columns. This column. Okay, we go to this one, go to object assignment, things labels for the frame. And you can see you have C1, C1, C2, C3, C4, C38. You have around 39 or 40 column in each floor. C1. Okay, so this is the labeling. You can go to this one and assign object assignment label and press OK and do it. Now, after we know this, show the font. So let's go to the roof level. So let's continue it. See here C1, continue up, C1, continue C1, and etc. For the walls, there's something called shell, and the columns we call it frame. For the wall, we're going to label and see. This is wall 7, wall 1, wall 2, wall 3, wall 4, wall 5, wall 6, wall 7. We have 7 walls. Okay. And we have here the same. And don't forget the retaining wall here. So until the top have the same. So this is the label you should know. Okay, and I will remove it from here. Object, shell, and then this one. Apply. So now we know how we model. We need to define. So the first thing we have defined the material. Now we need to define the columns. We already draw the column, but we need to define. By default, when you select like this, when you select using this button, when you select this and drag it and using arc layer, you can choose. If you change to grid layer, you will not. It will not work. So you need to define section property frame section. From the string section, we have fsec1, fsec2 until 13. So go to fsec1 and see. In fsec1, we have 700, 300. So I will name it this 700 times 300 column C 700 times or yeah column or I will name it C 700 or let's keep 300. Make sure that the material is 330 and go to show section properties. Here we can see the section properties and the area and the modulus and the inertia and all the properties of this section. And you can modify show rebars. You make sure that this one is column, not beams. Column, we have rebar for 120, 420. And usually I take the cover 30 millimeter and number of longitudinal bars along three direction, this direction, and number of longitudinal bars along two direction. You can make your own calculation. You can make your own calculation, or you can leave it for the design. I prefer to use the 1% reinforcement, minimum reinforcement ratio, which is if I use 700 multiplied by 300 divide by 100, we have 2100 area steel. I want to take bar 16. I should have 8 by 8, or I have 5 by 5. So let's take 3 here and 4 here to change to 16. And the confinement size. So the tie or the stirrups will use it 10 millimeter with the same section. So now we can see we have 1, 2, 3. This is modified. Modified. We have 3 along the 3 direction. We have 4 along the 2 direction. 1, 2, 3, 4. 1, 2, 3, 4, which is 8, 9, 10. So 10 multiplied by 201 will have 2010 area steel millimeter square. So I can use 5 or leave it 4. So now we have area steel 16 millimeter. So how I calculate this? I go to text. I use area steel minimum reinforcement ratio equal 101% in ACI code. Okay, so area concrete here is 700 times 300. You get the value, which is 200 meter, right? This, and then divide by 100 to be equal to 2100 millimeter. This will be the area steel. This one for the concrete, and now area steel should be 4/100. You will get 700 millimeters square. So which is equal to 10 or 11 to 16. Okay, so we'll have 11 bars or 12 or 10 bars to 16 for each. This is going to be have minimum reinforcement ratio in design. Or I always choose to use this, or you can double check with the ETABS in the design. Okay, so remove this. So now we have 700 and we have 300. And make sure it is rectangular column. This is the spread definition. Go to F62. Now it is vice versa. 300, 700. Okay, make sure modify shoulder boards, columns. I will use the same 30 millimeter. I will use here 4, 3, and here 16. I think it's 16. And now it is in different direction. So I will name it 300, 700. F63. We have 800, 300. So name it 800, 300. And modify the show rebars, columns, and make it 3T. And I will take the section here is 800 times 300. So we will have another steel. 100 times 300, you'll have 240,000 divided by 100. Also divided by 201. You will get 12, 16. So I take this 16, 12, 5, 3, 5, 5. Okay. So I'll take this also as percentage ratio written into this part. Go to F64. So we need to make it in a nice name. So now you have 130 multiplied by 300. So this is another column, quite big, but never mind, still column. 1,300. Now we need to put reinforcement 1,300 times 300 divided by 1. No, I want to take 5. Take 25 or 20 by 20 will be 5 4 will be around 12. So we'll have along the 3 direction 3, and then this one 5, 5, 10, 11, 12. So this one can be column, and F65 is 1,100 multiplied by 400. We get the same. Change this to cover. 1,100 multiplied by 400 divided by 100 divided by 314. We take this 314. So it will be in the 3 here, and it will be 6 here. So 6 by 3 we get this. So all using minimum reinforcement ratio. Okay, and let's go to F6. F6 is 900, 300. This is 300. Divide 30. 900 multiplied by 300. Divide by 100. Divide by 201. Or divide by 314. It will have 8. 2, 3.4. 3. Okay. and F7 is 900, 300, so 300 times 900. Let's change this to what? Or 3, 4, maybe. Okay, and F6, 8. We have 1000 by 300, so 300 times 1000 is changing the name. It's really important and make it easier for you. And here we can change this to 30 and make sure that to calculate the reinforcement for the minimum is good. Make your design easier. And 300 multiplied by 1000 divided by 100 will be 3000 divided by 201 or 201 can be a good choice or I'll take 314 10. So 3 by 5. Oh, sorry, this is a mistake. This one should be 5 and this one should be 3. So we finish this one. And that's section 8. Now the section for section 8. And let's continue. So 300 multiplied by 800, we'll get the reinforcement ratio here for the column, steel column. So 300 multiplied by 800 divided by 100, you get 2400 divide 2400 divide by 201, it will be 12. So 16 rebars is good. 16 rebars is good. So 12, 4, or 3, 5. Okay, change this again. Vice versa should be 5. This one should be 3. And save it. We still have sections 10, 11, 12, 13. The same process, we should continue 1100 multiplied by 300. It's repeated here. No. So 1100 multiplied by 300, modify and change this to 30, and to change this to 20, and take into consideration the 1% ratio minimum reinforcement times 300 divided by 100. You get 3300 divided by 314. You get 10 bars. So we have here 3, we'll get here 5, and put it like this. And continue for section 11. Section 11 will have 300 multiplied by 1300. So it is vice versa here. 1300 and modify show rebars, make this 30 and make this 5 and maybe continue to 16. Correct, continue. F section 12 will be 1300. We have it 1300, so we'll name it 1000 multiplied by 300 and modify show rebars. 1000 multiplied by 300 divided by 100 and take the 20 rebars, the 20 millimeters rebar. So we need 10 rebars. So take this along the 3 direction. This is the 3 direction. We'll keep it 3 and take this 4. And now it will be corrected. And section number 13 will be 1500 by 300. So 1500 multiplied by 300. We'll get the rebars for the columns. It will be very 1500 multiplied by 300 divided by 100 divided by 314. Maybe I need more. No, not 314. So we need this and then the third direction 3. This direction we need 6 or 7. So 6 plus 6, 12, 13, 14. So we have defined all the columns here in a proper way and change and make sure that we have the material the same. Okay, so we have the sections now. We have the wall, define the wall. define section for the wall sections. 125, 130, 135. We have it, and we need to define the slab. The slab here is is not inserted from the architect engineer. You should use the thickness of the slab. How to know the thickness of the slab? You need to know the the span between the largest span in the two-way system. We consider this as a two-way system. The largest span divided by the value based on the code. So if we go to the code, I have screenshot this one. Screen. Okay. If you go to screen to SCI code, minimum here. I have this minimum. We have without a drop panel. Okay, in our case, in ETABS, we have no drop panels. Okay, we have no drop panels, and we have no exterior edge, and we have the FY yield stress 120. So we use ln over 30. So in our case, we'll go to ln divide by 30. Maybe the maximum span here is, you can see here in the y direction 5.1, and here will be 0.25. So I will take it maximum for 6 meters a large span. So if you go to calculate, go to calculator, 6 meter times 100 in centimeter divide by 33, you will get 18 centimeter slab thickness. So I will make it rounding to 20 centimeter and define here section properties, slab section, modify the slab. Here will stay 200, material, I name it slab 200, and define and select object type. We have floors, select. So we'll select all. We select all and assign the shell slab thickness slab 200 as a slab. So we have the slab 200 here. We have all the columns. We have all the opening, and now the modeling has been completed. And if we can continue to see the wall, each wall should be name it as a pier. What is a pier? A pier means like all the loading should be directly come to the wall. So all the CG, the center of gravity of the wall will have a center of gravity. So we'll name it like a pier. Okay. So we will select or we'll define first section properties or define pier label. We have P1. We have how many walls here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 walls. Let me check. Let me double check again. Shell element sections. We have this one section should be label. Yeah. We have here 7. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 walls. So go again and remove this labeling and define section pier label P1, not duplicate P2, P3, P4, P5, P6, P7, P8, P9, P10, and P11. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we'll select all stories, this one, for the all stories. This one would be P1. Assign, shell, and peer label, and name it P1. This will be P1. And this for all stories will be P2. And this one will be P3. And this one for all stories, of course, should be P4. This one, P5. This one, P6. This one, P7. Go down, P7. Go to the P7. Go to this one, P8. This one, P9. This one, P10. And this one, P11. So we define the peer for all the walls. So we have all the peers now, and we define all. We made all the model now with the columns definition, with the material, with the slab. Slab thickness is 200. Right click and see. You can see for the columns. For example, you want to see this column label. You can see the properties is 700, 300. Okay, and name C19 and view. And what else we should define? We should define also the boundary conditions we already defined. We need to define the diaphragm. The diaphragm is really important. What is the diaphragm definition? The diaphragm definition is when the lateral load comes, it transmits all the load from the horizontal element to the vertical element. It is have a relation between the stiffness of the shear wall with respect to the stiffness of the uh, the stiffness of the vertical element with respect to the stiffness of the floor. So usually, and we define the slab as a rigid, The diaphragm would be rigid because this slab have a few small openings. So we are going to use the rigid. So we go to define section. Let's define. Select object type for the floor. Roof 1 is different, one story. For roof 1, assign shell and go to diaphragm. We consider this as diaphragm 1, so you can see all the points are transmitted into together. They will move together in the diaphragm under the center of gravity of the floor. You can add another diaphragm, see the rigidity diaphragm 2. So we'll go to the second slab for the all stories or similar stories. Select this one and go down until this one, modify, add a new diaphragm, V2, and say OK. We have diaphragm 2, then we have assigned, apply. So we have now right click diaphragm 2. If we go to the roof, we right click, we have diaphragm 1, and the typical we have diaphragm 2. because it have different shape and different features. We go to ground floor and assign this one only. Remove the assignment. Go to this one story. Okay. Assign, modify, add a new diaphragm 3. Okay. And assign this one only for one story. Make sure it is one story. Okay. Assign diaphragm 3. So we will have diaphragm 3 here, and we will top have diaphragm 2, and in the roof we'll have diaphragm 1. So now we have defined the diaphragm, we have defined all the things needed in the model. So this is the modeling in this part. So I will take a break and return back to you. Thank you so much. Now we have already done the modeling for the whole building, and it's time to check, me and you, whether we have any problem with the model or not by using this option, analyze. Go to check model, and tick all of this. Yeah, tick this, select all better. So 1, 2, 3, 4, 5, 6, and 7. That's it. And you can press OK and wait for analyzing. So you receive a message of warning. Model has been checked. No warning message have been generated or were generated. So our modeling is 100% correct. Now, after we define the walls, we define the thickness of the slab by span length divided by 33 according to SI code. We know that each wall is about a pier. We define the opening here. We define the material and the frame section. This is the frame section that we have different frame sections, and we have different different wall sections. So after this, we should go to define the boundary condition just to double check ux, uy, rx, ry, rz. So all the boundary conditions are fixed. But as we need to know is to add the to define the load pattern. So also we did the diaphragm. Okay. So to define the load pattern, yes, go to define. There's something called load pattern. The load pattern is dead load and live load. That load, we have self-weight multiplier, which is equal to 1. The self-weight multiplier means the self-weight of the structure, the whole structure system, is have that load, which is self-weight multiplier should be 1. However, there should be also something called SIDL, which is superimposed dead load. Superimposed dead load is like the partitions, like the tires, like the plastering, the painting. This is called superimposed load, and you can go to that super that type and add below. So we have superimposed that load. So in this case, we need to define or assign the loading on the slab. But usually we have a peripheral beam here, a peripheral beam which is very negligible thickness is put it here, which present the facading of the building. Usually the building have a facade, right? So around the building. So this facade have a load. So we need to define this load. But what type of beam we should define? The beam usually we define as a negligible of inertia and thickness. Go to define frame section called concrete beam. Change this one and name it null beam, or and put it very tiny thickness like 5 mm and 5 mm. So we have modifier and we have design for moment. So this one is beam, we name it null beam with the same material as a slab. 30 megapascal. So we go to the plan view, okay, for the eighth floor and try to all similar stories here. Similar stories. So we go to null beam here. Change null beam and try to draw straight line here. Straight line. Continuously pushing this point and pushing to this edge. And we're trying to show you how you need to design a realistic structure. This point, continue, and continue. Okay, and continue putting the beams on the peripheral boundaries or edges of the slab. Remember, we are putting in a typical stories, which is related for the similar stories shape. So in this case, we have null beam, right click, null beam, right click, null beam, and you can see it's 8, 7, 6, 5, 4, 3, 2, and 1, and the first floor have the same peripheral beam. So what about the ground floor? Of course, you can add something on the ground floor, but usually we put the facade in the top level, but we'll put now on ground floor here, where the garage could be, non-zero the garage could be. So now we draw the null beam again, starting from this point to this point, downward to this point, and continuously reaching from this side. It's not necessary because we have. So this is the beam, and still have the rooftop. The rooftop also have done a mistake here. Mistake. Remove this, undo. It should be only on the one story. So be careful again. Null, go to this joint and continue to the end of this joint. And continue to here. So we'll be fine. That not being here. So we still have to go to the rooftop. The rooftop have the same one story, and start with the beam here. The beam and here. Okay, so it's settled now. So if you can see now the model is completely done. And what is the purpose from putting the null beam? The purpose from putting the null beam is to put the SIDL load There should be load coming from the facade. Okay, so go to the 8th roof or 8 floor, okay, and select object properties frame section. There's something called none. You select this one, select, so you can see all the beams have been selected. All the beams have been selected. Okay, all the beams have been selected. So what is the purpose from selecting the beam is to assign the load, but to assign. Usually we will define. After define, we go to assign. So define. After selection, go to assign, go to frame, frame load. We have distributed load, right? Change this to SIDL. We put the load around the beam around 100 ton, which we have to take kilonewton meter. Distributed. So you can see here now the 10 meters have been distributed around the building. So all the load have been distributed here around the building. So you should take into consideration this stage and this step. So don't miss or forget this step. So we define now this one, and you can now define or assign. Select object type, slab section or floors. You can say floor, assign the floor, and assign shell load uniformly distributed for SIDL. We will take it like examples. Let's take it 3.5 kilonewton per meter square for the superimposed density value is 3.5. Right click on it, you can see the load is 3.5 for the SIDL. And you can see here the same 3.5. You can see 3.5 and 3.5. So after defining the dead load or the superimposed dead load, we need to go to define the superimposed dead load for order, which need to define the live load. How to define the live load? In the live load, there's a code called ASCE, minimum design load for building and other structure. This is the code. Is American minimum design load for building and other structure. The document used both for international system of units and customer units. This is familiar. This is for American Society of Civil Engineers. We follow the American Society of Civil Engineers in designing the life, in assigning the life load for the building or any type of building. In our case, we need to search for residential building. The residential building has a specific life load, so we go to life load here. Just try to find the life load. Life load. There should be a big table specifying the load. The table. Okay, here's the table. I guess here's the table, or sorry, it takes time to find it, but yeah, this is the table. We have two tables, table 4.1 or 4.1, okay, page 41. We have live load, the uniform live load in kilonewton per meter square or in pound per feet square. So apartment, see residential. Okay, let's go to residential. Where's the residential? Okay, here's residential. Residential, we have several types. We have uninhabitable attics or without storage. We have uninhabitable attics with storage. We have habitable attics and sleeping areas, and we have all other areas except stairs and balconies. So in our case, we should take this all other areas except stairs and balconies, which is equal 40 pound per feet or 1.92 kilonewton per meter square. So we know the life load for this one is 1.92 kilonewton per meter square. So here we have a lot of types of building. You need libraries, you can find the hotels, hospitals, and the garage, passenger vehicles only. So in our case, we'll put 1.92 kilonewton per meter square as residential for except stairs and balconies. And there is also for the roof, I guess. If sometimes you put the roof have different load. The roof have different load. Okay, here we have different type of loading. Ordinary flat capped roofs, roof used for promenade purposes, roof used for roof garden, or roof used for other special purposes, primary roof members exposed to work floor, all other occupancies, or roof surface and maintenance work. In our case, we don't have any specific use. We'll make it the same as the other slab. So the design will be the same, and we'll take the live load the same because we don't know until now what is the purposes of having the roof. But we can, you based on your purpose, you can select 4.79, 2.87, 0.96. In our case, we will take all the same in the residential, 1.92 kilonewton per meter square. So go back to our model and tabs. So we go to select object type, we go to floors, okay, assign. So we have be careful that make sure that you have assigned. Assign shell load uniformly changes to live load and put it 1.92 kilonewton per meter square. So in this case, we have the live load. Right click, we have dead load superimposed. We have live load 1.92, and we have the self weight of the building. So we have different type of loading, and for the roof as well. For the roof as well, we'll take 1.92. For the preferred null beam, have also load 10 km per meter run. So the model have been completed now. And one more thing before we finish this session is I want to make sure that the floor and the walls they are constrained. They are connected together. So how to make this? Just select object type or properties, object type, and we'll select the wall as the floor and select. Okay, we have selected the wall and the floor and go to assign shell, and well, we have here auto edge constraint. Okay, make sure that we have auto edge constraint. Just make sure don't create edge constraint. Create edge constraint around the wall and floor. Apply for full structure. Apply. Okay, so you have EC here as constraint. You have EC edge constraint here and there. So in this case, we have completely done the modeling with the floor, with the slab, with the wall, with the pier, with the diaphragm, with assigning the load. Still, we need to continue about defining the load combination. The load combination, we have a lot of combination to be added. We have also a lot of defined load cases that we need to define, like defined load pattern here. We have wind load, we have seismic, we have wind, we have seismic based on the code they are using. So in this case, we have finished the third session for the modeling. The modeling here is explained in details, and you can follow this one. Thank you so much, and see you next in the next video. Okay, thank you so much, and goodbye.